Afternoon, everyone. My time started, so I'll ask you to. So as the sign says, my name's Jason Hrncir. I'm a perimeter security engineer with Schlumberger. And the topic that I'm here to talk with you about is what we've done putting workloads on Google Cloud Platform and securing them with Palo Alto VM series firewalls. Schlumberger is a global oilfield services company. We have 100,000 plus employees in 85 plus countries around the world, and we have data centers in 10 of those countries currently. I'm a perimeter security engineer. I have a background in networking as well, and the reason I'm here standing before you talking is because what we're doing is pursuing a hybrid multi-cloud strategy. And I have a feeling that a lot of you are either choosing to do this or have ended up in this boat or are investigating it. What we'll talk about today, this is kind of the agenda, why one would even want to look at hybrid multi-cloud topology or strategy, what requirements we'll need of the pieces that make up a hybrid multi-cloud model, what this hybrid multi-cloud model looks like when there are VM series Palo Altos in play, and then the strengths and challenges of deploying VM series on the Google Cloud Platform. We'll start with the first question, why would anyone want to look at this model? Why go hybrid multi-cloud? And before we do that, we'll define what I mean when I say hybrid multi-cloud. And I think this is kind of the consensus definition. Hybrid means a combination, of course, of on-prem data centers and private cloud data centers and some sort of connectivity between them. Multi-cloud just means you've got connectivity to more than one cloud vendor. And when I'm talking private cloud, I specifically mean infrastructure as a services, private cloud resources, and hybrid multi-cloud, meaning all of the above, a combination of on-prem, good connectivity to more than one cloud provider. And if you're looking at my slide and thinking, did this dude just try to make a weather pun because he found an icon that says partly cloudy? Yes. Why do we even want to look at hybrid multi-cloud? So the driving factors, the things that make it seem reasonable or advantageous are that you can, with connections to multiple cloud providers, and maintaining your on-prem resources, you're leveraging the strengths of each provider, right? You can make use of any of the new functions and services that each of these providers turn up and make available to you. This is also very developer friendly. Your application developers love to be able to use the nice new features that any of the cloud providers come up with. They like to not be tied to particular features if you only have one set of resources or one cloud provider that you're working with, or specifically stuck to the on-prem resources. Workload portability, if that's an issue for you, you can spin up loads and move loads around. Back on developer friendly, the microservices model that a lot of folks or have been pursuing for quite some time also fits very well in a multi-cloud, multi-vendor strategy, because these components of a microservices architecture don't have to be statefully aware of each other, which means they don't even have to sit on the same platform. So they can just talk amongst themselves between them. Again, back to leveraging the strengths of each provider. Workload portability, application migration. I know I'm not, I think we were all not terribly surprised by how slow lift and shift migrations can go. We were hoping for more, but many of us are still in process, and we know that whether you're picking stuff up and actually trying to move it to the cloud as is or re-architecting as it goes, if you have the 2 or 3 or 4 environments live with good connectivity between them so your app developers can re-architect as they go, that's really what they want. So what are we looking, if we're going to have these components kind of tied together, what do we really want out of this infrastructure that makes up this combined data center? And to answer that, I'm going to take a step back and talk first about what we had in the past. So this is kind of a block model of what our traditional on-prem data centers look like. Layer 3 zones, each of these blocks represents kind of a security zone in the firewall zone sense, not necessarily in the Google network, GCP network sense of the word zone. But a layer 3 zone, you have connectivity to the internet, you have some sort of a DMZ zone, you have infrastructure that supports that DMZ. In an intermediate, you may have a production zone, dev, QA, test, sandbox, those sorts of things. You have good connectivity to the internet, you have good connectivity to your corporate network, where you deploy your, just kind of the traditional IT business systems data center model with layer 3 zones and next-gen firewalls between them. I assume since we're all at this same conference, we're probably following the data center model with Palo Altos in between the zones on-prem. So if we say that that's what we had, and we know that what we want is the thing that I previously talked about, connectivity and access to multiple cloud vendors at one time, and the products that they offer, what do we really want this combo of infrastructure to provide? We want segmentation like we had on-prem between our resources in the cloud, east to west segmentation there. We want firewalls in between those zones. We want good access to both on-premise and cloud resources at the same time, so our app developers are happy and can make the best use of each of the components that's available to them. We want good connectivity to be able to migrate apps from on-prem or to cloud, or vice versa, to move resources around. And a model that I haven't talked about or didn't talk about in the previous slide, but that we'll be coming back to, is external services hosting. So in the previous, where we kind of own the on-prem data center model, I know we and a lot of folks had use cases where our customer-facing kind of, the nice services that our users pay us for, our customers pay us for, are often hosted in an external environment, and that may be a colo, that may be a separate cloud instance, that may be us spinning up our own infrastructure and standing separate firewalls up in front of it. So we'd like whatever model we come up with to support that use case as well. And then in each of those cases, we want visibility and control of the traffic in between all of those components and in between all of the zones. So what might this look like? The things that I just described, hybrid multi-cloud, when VM series are in play. So first, kind of a topology diagram of a combination of the two things. We have hybrid multi-cloud connectivity, multiple clouds, GCP on the left, other folks represented on the right, and good internet connectivity, obviously, to our cloud platforms. We have some segmentation of zones in between them. We have visibility and control of that traffic. We have good connectivity back to our on-premise data centers. And we still have our on-premise data centers, probably because of reasons like performance or data residency or other legal requirements. And then we have good connectivity from our corporate network to those on-prem data centers, assuming those are the path between our cloud resources and our on-premise resources. Let's drill into just kind of one side of this and see what it looks like with Palo Alto's. Here's our Google Cloud Platform example, different layer 3 networks within the platform, and a VM series in between them, good internet access. So this looks like the top half of the model that we saw before, except all virtualized. Connectivity down to on-prem, where we have a physical firewall, same sort of model in the on-prem data center. Full set of PA features that we know and love in each case, traffic visibility and control in between each of those guys. It's kind of the combination of just resources in a cloud provider and resources on-prem seen as an extension one of the other. Here's that second use case that I mentioned. External applications you may need to host and present to your customers. And I present it separately just than the data center model, because it's, from what I've seen talking with my colleagues in the industry and other industries, is that the infrastructure is typically not necessarily shared between business systems and external facing systems, the products that we present to our customers. And so this is kind of a reimagining drawing of the load balancer sandwich type model that you guys see in the Palo Alto, how to deploy VM series on clouds, where you have users coming across the internet, hitting a load balancer, which then sends them to 2 or more VM series firewalls, which then does a source NAT and passes them on to the resources on the trusted side of the VM series. And in this case, we have an example of a load balancer fronting maybe a web farm or something like that. So those are the types of things that we need. Those are the requirements we have of the platform. What does GCP offer that makes this realistic or reasonable or advantageous? And the number one strength of Google Cloud Platform is the shared VPC model. And I think quite several of you probably have at least knowledge of this, if not experience with it. But within the umbrella of an organization on Google Cloud, you have different projects, and different projects are different administrative domains of control and have different resources assigned to them, different IAM roles, different owners, different quotas, different limits. And the ability to tie them together and make use of resources from one project in another is what the shared VPC model brings. And so in this example, also very similar to what you see in PA's documentation and Google's documentation, we see within the organization 3 projects. One of them is a host project that has some resources that can be available and shared by other projects within the organization. So here we have a VM series firewall fronting the internet that has a couple of networks on it. And those networks and that VM series firewall are under the control of the owner of the host project. And in this example, a couple of service projects are associated with that host, meaning instances in the service project can use resources in the host. So this example, say I'm the guy who manages the firewalls in the network within this GCP organization, and I spin up a host project, and I have my set of firewalls and some network resources, and maybe directory services or name services or something like that may live in there, the shared set of resources that I want to present to any service projects. And instances within those service projects can then make use of those resources by connecting to a subnet or a network in the shared VPC that I maintain and control. So that gives my app developers and owners and everything their own domain of control to spin up and bring down machines, build their apps, do what they need to do, but I still maintain visibility and control of the traffic as it goes either in between those networks or between the networks and the outside world. Oh, another strength of GCP is the Cloud Firewall. It's not unique to Google Cloud Platform, of course, but GCP firewalls function very similarly to access control lists, but they're applied at the VPC network level, so it's not necessarily ACLs that must be defined on each host. You define them in a group and apply them at the VPC network level. And if you're using VPC networks kind of in that model, like that shared DMZ, or the shared model with DMZ in the cloud and the on-prem and everything, if you're using kind of a shared block like that DMZ, but you need segmentation within it, for example, different groups of web front ends or something like that, that you don't want to be able to see each other, a good use case for Google Cloud Firewall is to segment that to reduce visibility of any portion of, or any set of resources in that zone, to restrict visibility of anything else within that zone, so that all traffic to and from those machines has to go to the VM series, and there can't be any lateral movement because the Google Cloud Firewall prevents that. Another high note to mention that we've seen on the VM series on GCP is that the performance numbers that both Google and Palo Alto print on the side of the box seem pretty accurate. Now, granted, the test case, the numbers that I have here are in a best case environment. They're all within one Google network zone, meaning like one Google data center, very low latency, very high bandwidth between them all. This is just iPerf traffic. It's a low number of sessions. No advanced features turned on. No IPsec, no threat, no nothing. So it's as if you basically took a physical Palo Alto out of the box, gave it a routing table and a basic config, and shoved a bunch of packets through it. The VMs seem to behave pretty close to what the real ones do, which is pretty good, honestly. Okay, so those were the nice things and some of the logic or idea behind why we'd want to move there. The problems that we see when bringing up VM series on GCP, the biggest problem is around high availability, and this is not necessarily a problem that's unique to VM series on GCP. When a cloud provider abstracts away the network level and a lot of the functions, the VMs, since the VM series firewall is to the underlying cloud fabric, a VM, it doesn't necessarily have visibility like a physical firewall would to what's going on with the real NICs. We lose native HA, we lose session sync, and the only high availability or failover or resiliency options that we have are those dictated by the functions of the cloud, by what the cloud provides us. And on GCP, that means load balancers or routing, and each has its limitations. So an example of a load balancer, here we have a load balancer fronting a pair of VM series with an internet connection on the left. That works fine in one direction. Imagine a web cluster or some cluster of resources on the right side. The load balancer can forward traffic to an interface of the VM series. A truth of the multi-NIC functionality of VMs on GCP right now is that load balancers can only forward to the first NIC, to NIC 0 of any VM. So in the Palo Alto VM series world, that means an interface. We'll talk about that in a second. That traffic can then be source natted and passed on to whatever resources then are on this side of the firewall. And the return traffic in that session can return to the firewall that originated or that passed it through and natted it. The downside is because a load balancer can only be associated with one interface of the PA VM, I can't have another load balancer associated with it. So I can't do like a two-way if the server needs to initiate a connection to the outside for whatever reason. There's no way to associate a load balancer with any other interfaces. I'll come back to the whole one NIC and load balancer to one group of firewalls in a moment, but the other mechanism that we have to provide some sort of failover or high availability is routing-based controls. And routing in networks and subnets on GCP actually does have some nice functions in that you can have multiple routes to the same destination. Those routes can have the same weight or priority or different weights or priorities. That means that they can support functions like ECMP among a group of resources, and you can do weight-based or priority-based routing failover. So in this example, we have two VM series, PA1 and PA2. We want our PA1 to be the primary path and PA2 to be the secondary path. So our routing table in the network where this particular resource sits says your priority 100 next hop for your default is going to be the NIC of PA1, and you also have another route with a higher number priority pointing to NIC1 of PA2. The priority number lower is better in this case. I don't necessarily understand that, but okay. The routes only change in the routing table when the destination, when the next hop, that shouldn't say destination, when the next hop becomes unavailable. So if I were to go to the Google Cloud Console and turn off or stop PA1, within a short amount of time, it would become unavailable. The routing table would change. The system would remove that first priority 100 route. The second priority 200 route would become active, and traffic would forward through that other VM series firewall. The reason that this slide is in a challenges section of my talk is that whole when the next hop becomes unavailable. From what I can see, a VM only becomes unavailable as a next hop when it's in a stopped state. And that means not when you're rebooting, like when it's on the way, not when it's on the way down, not when it's on the way back up, not when it's totally up but someone made a routing mistake in the routing table and so traffic isn't actually going through it, not when it's rebuilding its log database after a PAN-OS upgrade. It has to be absolutely completely stopped from GCP's point of view before the routing table changes. So that's a limitation to keep in mind. Some examples of the different topologies. So those are basically the two tools that you have in your tool belt for doing any sort of failover or HA-like behavior between multiple VM series firewalls on GCP. So let's look at the combination of them for some of our examples so far. So here's the load balancer plus routing failover for a simple internet-facing service like a web cluster, where the inbound connections are sent to a load balancer. It then forwards them on to a group of PAs. The PAs source snap the requests and pass it on to the destination web group or group of resources fronted by another load balancer, whatever. Traffic initiated in the other direction then is controlled by the routing failover mechanism we saw, where the primary PA1 is selected because it has the better path in the routing table, and should it become unavailable offline, the secondary path or PA2 would become available. What does that look like with multiple zones? So here's a simple two-tier application where we're doing routing failover, and you can kind of imagine that the left side of the screen is that same load balancer fronting internet incoming traffic that we had a while ago. Traffic in between these zones, if we have a web application zone that talks to a database zone. Same model where the NICs of one of the PAs, one of the VM series PAs are preferred at a given time, and should that virtual machine become unavailable, that VM series firewall become unavailable, routing tables change, and all of the traffic then shifts over to the second VM series. Now, as mentioned before, since there's no state sync in between these guys, sessions are dropped, so you don't, it's not seamless failover, and as mentioned, the failover time's 30 seconds plus. And what we saw was, if I do this exactly, and then I have traffic running between the zones, and I go click the stop button on the cloud console, it's about 30 seconds or so before everything notices that the VM is gone and traffic shifts over. Now VM2, PA2 is the primary path between the two zones, and everything continues with new sessions. Rebooting a VM, longer than that, because there's some time as it goes down, some time as it comes back up before it's able to forward traffic. So what this means, and what I would recommend if you're going to follow this model, for any sort of planned maintenance that you want to do, script the routing changes beforehand. So if I had this set up where my PA1 VM series was my primary between a handful of zones, and I needed to do maintenance like in a PAN-OS upgrade, I would upgrade my secondary obviously first, and then I would prepare a script that, say, for example, changed that first route's priority to 300 in both of those routing tables, hit go. Within a second, those updates are made and traffic moves over. No stateful failover again, of course, but all the testing we've seen, it's quite quick. Your standard ping test at 1 second return time doesn't drop anything, so the scripted routing change does make that nice. And the only other example that I've kind of prepared, since the tools that we have and the use cases that I outlined were pretty much addressed by just these two, is just a lesson learned that we found, which was a headache. If you find the need, so this is our model from a few minutes ago where it's a shared VPC with a host project with some resources in it, and if we have a need to put a firewall, a VM series firewall, or any other multi-NIC VM in a service project, you run into the same limitation of not being able to forward traffic to any interface except NIC 0 on a VM on GCP. And so we kind of ran into a bit of a headache here where we wanted to say, okay, we have a VPC, a shared VPC network that lives in our host project, and we'd like to have an interface on the VM series in this service project that can then pass traffic onto instances that live behind it. Great, that works fine. What's difficult is we didn't have a way to manage that firewall without doing something creative, right? Because I can't land that management interface. I forgot to talk about swap. I'll get back to that. You can't have that management interface. You can't forward traffic from a host project to the management interface because it's not the first NIC on that VM. So just to finish this example, for workarounds for this, you could do something like do your management through a tunnel, but then that, of course, means that the tunnel has to be up all the time for you to get through it to do management. Something that we looked at as an alternative is to put some other box there that has an interface that you can land the connection on, and then it performs a routing NAT function to let you get access to your management interface. Swap interface, one of these guys had some mention of it. Let's go to 2.4. Yes, okay. Thank you. When a VM series, any VM series comes up, and you look in the host of the virtual host, you'll notice that the first NIC in that configuration is the management NIC on your virtual Palo Alto, on your VM series PA. That's true on the VM series run in-house or on other cloud platforms. Due to this feature functionality on GCP where traffic from some GCP components can only be sent to NIC 0, like load balancers, PA and probably in working with GCP to come up with an answer on this has built a mechanism that's well documented in their docs on how to get around this. So the situation is, if I deploy this out of the box and bring up two VM series and try to point a load balancer at the first NIC without doing anything strange or different or new to the VM series, the first NIC will be the management interface, which isn't going to forward any traffic, right? So there's a function called the swap function that after you bring a VM series live, you run a couple of commands on CLI, and it actually changes from GCP's point of view which NIC is NIC 0 and which NIC is NIC 1, so that you can take another one of the NICs that you want to forward traffic to and make it show as NIC 0 to the underlying fabric. And so that's something that you would have to do before the load balancer or before the forwarding traffic in the other slide that I showed would be able to pass any traffic between the interfaces. Okay, I've been doing a lot of talking and I'm out of examples, so has everything I said been relatively clear? The couple of failover, a couple of routing plus load balancer models. I think they've addressed most of the problems that we've seen. As long as you're willing to work within the caveats, know that routing failover does take a while, know that it's not stateful. Plan for any other scenarios where you may have an instance like that VM in a service VPC, where you can't necessarily forward traffic to more than one NIC. I talked a lot faster than I expected to, so Anybody have any questions?